Welcome to Homework Lib.
For this problem, I have taken the liberty of perfectly recreating the graph in the textbook, though it is still a great source that I recommend you look at in supplement to mine. We are given a little bit of a real-world example in that we have a graph and we are meant to parse some things about that graph. We have plotted against voltage the amps of the diode at given temperatures. So this temperature is 25 degrees Celsius, and our other temperature is I'm going to Kelvin all of a sudden, is 150 degrees Celsius. And what it wants us to find is the sensitivity for the diode thermometer, operated at 100 milliamps, which is here. And the sensitivity is defined by the change in voltage, so how much the voltage changes, for a given change in temperature, so how much the temperature changes, while the amps stay the same. So 0.1 amps or 100 milliamps. So if we were to calculate this, we look across and see, that's a straight line, isn't it? What our values are for our old and new configurations, and that should tell us what the sensitivity is. So let's start out with delta T. We end up the final configuration, because it's final minus initial, is 150 minus the initial, which is 20, equals 125 degrees Celsius. And we do the same thing for the voltage. Final minus initial, so 0.4 minus 0.6 is 0.2 volts. And if we plug that in for sensitivity, we get 0.2 volts divided by 125 degrees Celsius. So that's 200 millivolts. You get that the sensitivity is minus 1.6 millivolts per degree C. And since we have a multiple choice, we want to pick the closest thing to that. And that is, of course, going to be number D, which is minus 2.0 millivolts per degree C. So not too hard once we figure out how to read this particular graph.